So, what do you do when a PC that's practically brand new just dies? That's what we're getting into today. It's a really cool repair story that's kind of like a mystery novel, but for electronics. And it makes you think, what does a perfect fix even mean? Okay, so it all kicks off with this message from a customer. They're like, hey, I've had this mini PC for only 4 months and it's totally dead. And get this, they opened it up and found, well, a complete mess. This is where our little detective story really begins. All right, so the first peek inside, whoa, it's pretty dramatic. You've got two components on the motherboard that are just blown to bits. You'd think, okay, case closed, right? But nope, not so fast. When it comes to fixing electronics, the super obvious problem, it's usually just a red herring. Yeah, see, any experienced tech will tell you that just swapping out those burnt parts is a total waste of time. Those little explosions are just the symptom, you know? They're the loud, messy result of a much sneakier problem hiding somewhere else on the board. The real culprit is still out there. So the hunt is on, but the technician isn't looking for more fried components. Nope. They're on the trail of something you can't even see, a short circuit. And trust me, this is the real bad guy in our story. So what is a short circuit anyway? The easiest way to think about it is like a massive unexpected roadblock on a superhighway. All the traffic, in this case electricity, grinds to a halt. Power can't get where it needs to go, and the whole system just shuts down. The trick is finding exactly where that roadblock is. So how do you find this invisible problem? Well, you follow the procedure. Step one is the visual inspection. You know, those burnt up parts, which turn out to be inductors. They're supposed to help manage power. Step two, you grab a multimeter, and yep, it confirms there's a dead short on the main power line. And for step three, you bring out the cool stuff. You inject a little bit of power and see what part of the board starts to heat up. Okay, so the short is confirmed. Now it's time to bring in the big guns. A regular inspection just isn't going to cut it here. Our tech needs a special tool, something that can literally see the invisible. And that tool is the thermal camera. This thing is the key to the whole operation. It doesn't see light like our eyes do, it sees heat. A short circuit, well, it's basically like a tiny fever on the motherboard, and this camera is the ultimate thermometer for finding it. So the technician carefully injects just 1 volt into the board. It's not enough to cause any more damage, but it's just enough to make our little culprit show its face. So the big question is, what's gonna light up? And bingo, there it is. It's not those big, ugly, exploded parts at all. It's one single, tiny capacitor with a crack you can barely even see. And it's glowing white hot, like a tiny little sun. This one microscopic part, this was the secret agent that took down the whole computer. Okay, so the bad part has been found and yanked off the board. Now it's time to fix things. But this is where the story gets really interesting, because the technician decides to do something, well, something that might surprise you. It's definitely not the by-the-book repair. All right, so here are the two options on the table. You've got the proper fix. Replace those two fried inductors. The problem is that requires a ton of heat, and you're working right next to plastic parts that could easily melt. Big risk. Then you have option two, the practical fix. Just ignore them. Bypass them completely with a nice solid glob of solder. And our tech goes with the practical route. A clean solder bridge is made right where those inductors used to be. They put the whole PC back together, plug it in, and it works. Just like that. The fan starts spinning, the screen comes to life. The unconventional fix was a total success. But that begs the question, right? Why do it that way? Why not just stick to the original factory design? Well, this is where we get into the real philosophy of what it means to be a good repair technician. So here's the technician's logic. On this particular board, those inductors were basically acting like a fuse. But here's the thing. The power adapter, the charger itself, already has a protection circuit that does the exact same thing. So if another short were to happen, the charger would just cut the power. The inductors were basically extra. They were redundant. His argument is pretty straightforward, you know? Why risk damaging the board even more with a tricky repair, just to put back a part that isn't really needed? He's making the case that the simple, strong solder bridge is actually the perfect repair for the situation because it's reliable and totally safe. And really, that's the heart of the matter. The goal isn't to be a robot and just copy what the factory did. The real goal is to get the customer's computer working again, safely, reliably, and for a price that's fair. It's all about providing a practical solution, not about chasing some idea of design purity. So it leaves us with this really interesting question to chew on, right? When does trying to be perfect actually get in the way of doing something that's just good? In this crazy world of complex electronics, maybe the best fix isn't always about making something exactly like it was new. Maybe sometimes it's about making it work even better. Something to think about. Thanks for checking out this explainer.